So moving on, I've made a bracket, a replacement bracket, or at least it's 3/4 made, and it was a bit tricky. The first bend was alright, but the second bend I had to use a huge lump of steel, well not huge but quite a heavy duty piece of steel as a former, so I could clamp it to one side and then bend the other side over it. So, and of course stainless doesn't bend that easily. So let's just have a look. So here it is. It's on a block of wood because I slid that piece of hardwood in there to drill the holes after I'd bent it all up, just so that they were parallel and what have you. Let's just pull that out of there. So I bent this up, drilled the hole in the middle, put the piece of wood in, drilled through, and now we just need to form this shape. I could just leave it like that, but I think trim her up and grind around. And in the last video we were talking about this wee bolt, how I think the welding on that had started the crack. That might be the case. What's happening? We've got some sunshine on this and I'm trying to work out which way to go. There we go. And do we go forwards? Yes, there we go. That's a bit weird. We've got some sunbeams coming in through the window. Anyway, well, look at this now. It's a perfect lock tab. And as long as this thread is long enough, then that should go down in there and prevent it from spinning. So there's various people, as we've covered, given suggestions on this, but that might just do it. So I'm just going to grind that up and then put it all back together. So there we are, in place, and there is a bit of thread sticking out. Focus, come on, focus, get on with it. There we go. There's a bit of thread sticking out beyond the nylock, which is fine. One of the comments last time was saying straighten the springs up by putting a piece of tube inside. These already have a piece of tube inside that tapers off towards that end, and it's just sort of bent where that taper finishes. I think we shall just leave these. Yeah, you can see it inside there. We're just going to leave these and see what happens. But as you can see, that's a much beefier bracket. I actually had to grind a little bit off the head of that bolt where it's welded to that, the remainders of the original bracket, just so that that middle spring mounting bracket would fit in there. So we're all done. On with the next bit. Right, it's the first calm day for a while, and we're getting on with this turbine repair, and I just wanted to take this piece off here, which is the aerofoil. You imagine the wind's coming this way, so this is aerofoil shaped to allow the wind to come round the pole, because the blades are at the back, so it wants to be as smooth an airflow as possible. And there's loads of cable ties here, so the only thing to do here is to cut them off. We're going to just do that, and it feels like some of them are a bit rotten anyway. That one certainly, and that one's just snapped. and these ones are tree ties, but they've about had it. So let's just see. There's another tie there. So let's just grab hold of the camera and show you various bits. Just there's a big face mounted bearing and it's greasable. So that's the main pivot. And this framework comes down here and takes up that brace, and then just in there are 4 rollers, and they sort of wear a bit as well, so I'll have to inspect those. So here's one of the main bearings. As you can see, it's greasable, and the other one is behind the brake up there. So what happens with the brake rope is the brake lever, for some strange reason, is in line with the wind shaft. So when the brake lever is not operated, that piece of bungee holds the brake rope away from the wind shaft, but when you operate it, it pulls tight and rubs on the wind shaft. A bit Mickey Mouse, really. So I've oiled the bolts that run through those rollers. I've tried not to oil the roller surfaces, little bits got on there, but basically it's between the inner roller and the bolt, and that bearing's been greased, and the 2 wind shaft bearings. I've also put some rubber grease and a bit of oil on those sliders there, and on the heel of that lever there I put some copper slip, just to try and make it work a bit better. So I've got a new rope on it. I'm just going to show you. You probably can't really see from this angle, so I'll move the camera. We'll show you the action of the brake. Hopefully that might work a little bit better than it has done recently. So the next thing to do is to put the covers back on. I think we've done everything we can do here. Put the covers back on, new cable ties, and that's a bit of a faff, so I'm going to do that off camera. And we've just about got the gin pole in place. So let's just pan down here and out a little bit, and there's the gin pole in place with a brace. How I got it there I'll tell you later, but it was a very steady process, and having seen it there now, maybe it's a bit on the tall side, but I used the steel that I got, so If I was to cut 2 foot off it and then decide it was too short, that'd be really difficult. The design of it will show in the operation, but a bit longer, so therefore you have less stress on the cable, is better than a bit too short. So this is a 4-ton strop in a choker, so that's 0.8 of the strength, so that's more than enough. And this is a Turbine winch. It's 1.5 ton lift, 3 ton pull, so hopefully that'll be enough. It's on 11mm steel cable, and the cable that goes up and over the gin pole's 11mm. That's more than enough. So at some point we're going to just give this a little tug and see what happens. So here we are, and just there, which is an original stay mounting point, I've attached the cable, 11mm cable, and it goes up, and we tried to put some pressure on this thing just to test it, and it all went pear-shaped. There you go, typical. So it's bent just below where the brace is attached, just there, and you go, why did that happen? The pulley at the top should have spun round easily, and you would have thought there'd been equal stress both sides, but obviously not. So we got to have a bit of a redesign here. Didn't put a huge amount of pressure on this, and I wasn't at the time running a camera looking at the turbine. I just thought I'll put a bit of pressure on this winch, see what happens, and it tightened up, and I thought, oh, this is alright, and then suddenly went slack. In retrospect, I think obviously maybe the gin pole's a bit long and the stay is too short and should have gone higher up. But let's just have a look at the stay mounting point. But if you think about it, if the wheel wasn't, if there was unequal pressure either side of that wheel, then between the wheel and where the stay is a lever. So it makes sense that it's bent there. That's sort of a fulcrum point. And the attachment point for the stay, as you can see, it has bent as well. And I'm guessing I must have put 2 tons of pressure on that cable. That's just a real vague guess. Anyway, more of the same, onwards and upwards, theoretically.